Let's attack this fraction problem. So first of all, I see we're dividing two fractions, which if you recall, we never divide with fractions, we multiply by the reciprocal. So I have already changed to multiplication and flipped my second fraction around. Now, as you look at all these numerators and denominators, you should automatically be thinking factor, either by GCFing, unfoiling, or grouping. So in this first numerator, x squared minus 2x minus 8, this can be unfoiled into x and x, 4 and 2. The bigger number gets the middle sign, so minus, plus. The other part of this that can be unfoiled is the denominator of the last fraction. This is the difference of perfect squares here. 2 times 2 will give us 4. X times x will give us x squared. And a plus and a minus will cancel the outers and the inners. So halfway factored out. Now let's go to the numerator of that second fraction. This looks like it can be GCF'd. The greatest common factor of 9x squared and 18x is 9x. And when we pull that out of both those terms, that will leave us an x minus 2. One piece to go. And here in the denominator of the first fraction, we're going to have to group this because there's no GCF for all four terms. There's no unfoiling with the cubic. So we are going to split this in half and factor out each half using the GCF. So x cubed minus 4x squared, the GCF is x squared. And the second half, the GCF, is going to be negative 1. And when we divide both those pieces by negative 1, that'll leave us x minus 4. And notice these two parentheses are the same, so as we look at this whole expression, we've got a new greatest common factor that we can pull out. So when we pull out that x minus 4 from both the halves, that leaves us the x squared minus 1. And then you should also recognize here that x squared minus 1 is the difference of perfect squares, so we can actually unfoil that into x minus 1, x plus 1. And now I believe we are all factored out, and now we can just cancel numerators and denominators that are the same. X plus 2, boop, boop, with 2 plus x. X minus 4 in the first fraction, boop, boop. And the last thing we can cancel, x minus 2 and 2 minus x, boop, boop, negative 1. And whatever's left over is our answer. So we have a negative 9x in the numerator, and x minus 1, x plus 1 in the denominator. These complex fractions look really nasty, but they're really easy. All you need to do is think about, I need a common denominator for all the little fractions inside of this humongous fraction. So my denominators of x, x squared, my least common denominator is x squared. So I want to turn all fractions to have x squared as denominators. So 1 is going to be x squared over x squared. To change x into x squared, I'm going to need to multiply by x on the top and the bottom. The last fraction, 27, already has the x squared as a denominator. 6 over x needs to be multiplied by x. And this 2 over 1 needs to be multiplied by x squared. And once you've got that common denominator, you can lose the common denominators. And now we just have to factor. X squared minus 12x plus 27. This is going to unfoil into x and x. Minus plus always goes minus minus in the parentheses. And numbers that times to 27 and add to 12 would be 9 and 3. In my denominator, 6x minus 2x squared, this can be GCF'd. Both of them have a greatest common factor of 2x. 6x divided by 2x is 3. 2x squared divided by 2x is x. And now I think there's a common factor that we can cancel out here. 3 minus x on the bottom and x minus 3 on the top. Boop, boop, to make negative 1. And what we have left is our answer. And I'm just going to leave it as negative 1 times x minus 9 over 2x. If you wanted to distribute up here in the numerator, you could change this to negative x plus 9, but you don't have to. You can leave it with the parentheses. Lastly, let's solve this equation involving fractions. So the first thing that I notice is on the left side of this equation, I am subtracting two fractions. Now I'm going to do two things. I'm going to add the opposite to change that into a plus sign. And now, knowing that I'm adding or subtracting these two fractions, I need a common denominator. So if I factor out this first denominator, this shows me what I can use as a common denominator throughout this problem. X minus 2, x plus 2. Because my second fraction already has an x minus 2, all it needs is x plus 2 on the bottom, and whatever I do on the bottom, I do on the top. And my last fraction has an x plus 2, it needs an x minus 2. Top and bottom. And now, with those common denominators throughout, we can just ignore these. Denominators, gone. And now all we have to do is solve this equation in the numerator. We got to do some distributing. Over on the right, we're going to have 6x minus 12. On the left, we've got this 3x plus. Now negative 1 times x is negative 1x, and negative 1 times positive 2 is negative 2. Combining like terms. And solving for x, minusing the 2x to the right, adding the 12 to the left, gives us our answer for x of 10/4, or 5/2 if we reduce. And just as a simple check, we should check to make sure that this answer of 2.5 does not make any of our fractions from the beginning undefined. No, the only two numbers that would make these fractions undefined would be positive 2 and negative 2. So 2.5 is our answer.